I know I could point it at the source code, I just don't care right now. I'm not interested in the source level trace. Which multi-queue function is this? This is try receive. This has got to just be some thread is in an infinite try receive loop. And so it wouldn't be the WebSocket thread because I don't think any clients are connected right now. Although it's kind of hard to start this without connecting any clients right now. So it could be. Anyway, I think the next thing I want to do is use potentially just the Visual C debugger again, or WinBag, to try to see which thread this is. And then just take it kind of manually from there. I think the problem is actually probably pretty close to being apparent. But anyway, oh, did YouTube just restart again? Jeez. Sorry about that. Anyway, I've got to use the restroom. I'll be right back. Sorry this stream has been full of so many glitches. This is what I get for apparently using tons of CPU on the same machine I'm streaming from. Alright, let's just attach WinBag to this thing. Wow, Luna, what a jump. WinBag, yay. Good old WinBag. This is basically like Microsoft's equivalent to GDB. It's kind of low level, but works pretty much anywhere. Oh, but these aren't in alphabetical order, are they? Here it is. System order, I see. Are you still connecting? Are you failing to connect? Mako MK says, I guess now it's officially 2 streams. Yeah, I've been streaming on both Twitch and YouTube for a long time. Really? Would it work better if I launch it? Maybe we're just having trouble attaching. is this? Oh, did I accidentally picked the 32-bit version of WinDebug. I thought I picked the 64 version last time. Hey, CloudButt. Cloud, you want the monofilament also? Or zip ties, or just any other fucking thing on my desk. No, you can't eat this. Stop it. Oh, jeez, Cloud, just stop. ETW. I mean... Okay. This is, it's really frustrating that, like, you have a problem with a profiler, and the solution is never, here's the solution to fix it. The solution is try a different profiler. Okay, we've got an empty console there. Where is my command window? There it is. Okay, maybe it was just off screen, like everything is on this monitor setup when it isn't perfect. Okay. So I think we just need to continue an exception. Terminate process. Oh, we need to give it the right starting directory because it could not read its config file. I can't set the current directory here, can I? Maybe that isn't straightforward. I mean, I could run winbag from the command line in the directory I want it in. Where is winbag? I thought it would be like program files / Microsoft debugging tools. But let's check this. Windows kits. How did that end up in my paste buffer? I hate closing the thing and not having... It's very easy to accidentally copy something in the console here. Anyway, target or debug /. Okay, I think that might be what I want. So I've got, if I put everything back on the screen, we've got winbag, it's running bot controller, we've got an empty console here. Let's see if it makes progress. That's better. Bot controller's working. Now let's breakpoint. Very simple debug sampling. And I actually want the thread view. All these windows are opening off screen. Robert says YouTube down again. Are you sure? It says I've been streaming for 10 minutes now. Can you reload? Okay, I think I want call stack and processes and threads. Robert says MPV/YTDL only getting 720p from Twitch. That's not my thing. Like, I am giving Twitch 1080p video. I don't know why you're getting 720p, but that's not my fault. You might have to tell it to use a particular resolution by default with YouTube download. Okay. So we can actually see what some of these threads are. So this is the watchdog thread. It is sleeping. That's some NT worker thread, another NT worker thread. This one is this is the configuration save thread, which is waiting for work to do, which is good. This is the bot communication thread, which is waiting for a socket, a packet to come in over a socket. This is the main HTTP server thread, which it looks like is waiting for another thread to join. Interesting. This is another WebSocket related thread. It's waiting for a connection to be accepted. This is another WebSocket related thread. This is like the HTTP server listener pool, and it's also sleeping. Another HTTP server thread that's waiting for accept. There's like a whole pool of these for incoming connections. Maybe more of these than we need. Why do we have so many? Really? That's a lot of accept threads. Maybe we can configure this down some. Oh, what I wouldn't give for thread apply all backtrace right now. Hey, Cloud, don't destroy all the furniture. Why is my entire world made of accept threads? Okay, so then we're finally over the accept threads. Here's the gamepad thread, which is sleeping. Good. The gamepad thread does do a lot of polling, but it only polls at like 60 or 100 hertz or so. Oh my gosh. Okay, Morgan. Threads are being dumb. That doesn't say anything. There's no information in that statement except to dismiss the problem that's being asked. That doesn't help at all. There's... like, all that does is push people further from the answer. The thing I'm trying to look for here is that the bot server is using a lot more CPU than I expect it to. So I'm looking for a particular thread that's not blocked where I expect it to be. It's nothing about threads being dumb. Threads are fine. The implementation of threads is fine. Everything that I'm running in these threads, for the most part, is fine. Like, this is something that bothers me a lot with coding, is like this thing where people tend to catastrophize all the time. It's like, this isn't working. You've got to completely abandon ship and switch libraries and switch projects and do it a completely different way. And that's usually not the answer. Sometimes it is, but usually stick with it a little bit more first, please. This might be important. I think this is fine though. This is the main controller thread. You can tell because it's running this controller function, and it is waiting for the next message here. I think that's fine. Well, I think what we're looking for is some case where we are using like a non-blocking read when we should have been using a blocking read or something like that. And then Andre is asking, does it make any difference if the build is a release version? Right here, it doesn't so much. The things I'm looking at are not like anything the compiler is going to have much say in. It's all like how I'm using the operating system. So the actual efficiency of the code involved matters almost zero for this particular investigation. So like debug versus release is going to be more about the visibility into the system. Yeah, no, sorry, I don't mean to like bite Morgan's head off or anything here. I get really frustrated with people who want to interject non-answers to real questions frequently. It's a pet peeve of mine. Okay, let's keep going. This was thread 74. LED animators, rendering some frames. This is actually rendering, it isn't blocked. So this thread could be part of the problem. This thread is supposed to be rate limited, so maybe the rate limiting is broken, but that would not explain what I was seeing in the sampling profiler, because this thread does not spend a lot of time, like this thread doesn't wait for messages at all, so we shouldn't be seeing a lot of CPU time spent trying to get messages. This one, this is something related to the gamepad. Why is that hanging out inside spawn thread? This is something else gamepad related, but I don't know what this is off the top of my head. It is sleeping though, so I'm not going to worry too much. That is... I think this is a new thread the debugger created just so we could break in. Oh, and this seems to be the one that's chewing up CPU. Of course, the very last one. That's usually how it works. This is one of the WebSocket receivers. Oh! I wonder if this is a failure of the automatic latency control in the WebSocket receiver. Okay, I'll buy it. Taylor, why does seeing panic commands make you laugh a little? Why is it funny that software handles errors sometimes? Oh, I see. Make OMK, when they said, I guess it's now officially 2 streams, was because we were offline long enough that apparently YouTube didn't paste the streams together. Usually, if there's a small outage, YouTube will continue them as 1 stream, but... Bob says, you don't have to understand the problem if you can just dismiss the problem. Yeah, that culture exactly. And it shows up in a lot of really friendly ways. Like, people are like really friendly and awesome, but still dismiss the problem when they don't know the answer. And it's just frustrating. Like, if you don't know, let someone else give a better answer. Also, which client is this associated with? It could be the web server that or the web browser that I just closed, the one that it made. Anyway, let's maybe just do some print debugging or something else simpler to get an idea of what the latency controls are doing in there. It's supposed to be coming up with a polling interval for how frequently it batches together messages from the internal bus and throws them onto the WebSocket client. And it's possible that number got way too small and possibly ended up as 0. We need bot controller. It's not this one, is it? Is it? Because this should be a blocking receive. That receive we were in was the multi-queue, which is what the bus is implemented with. If it was the message send thread, I think it would be an MPSC channel. So that kind of absolves the latency control of any responsibility from this, if I'm analyzing it correctly so far. I should start naming all the threads. That would probably help. Andrew says, did you try the very sleepy sampling profiler? Yeah, we tried it and couldn't get it to actually run the profiler. It would show the list of modules and threads, and those actually showed the symbols. But then I tried just like running the profiler and it didn't seem to do anything. So maybe I was using it wrong, but it does seem like a problem. Yes, I know how to name the threads. I don't need the docs about how to name. Hey, girl. Usually when I'm saying, like, when I'm talking about the architectural direction, it doesn't mean I necessarily want, like, to immediately unfold documentation for every possible thing that we could use to implement that architecture. I don't know that that was the problem either. My free web is saying that Very Sleepy doesn't seem to work very well with Rust's debug information. I don't know that that was actually the problem. The debug information was in PDB format, and it seemed to be loading that fine. The problem was either something kind of weird, just related to it not wanting to start the sampling, or it was related to... Well, then the other problem actually... So yeah, Very Sleepy, I just don't know what that problem is. I don't know that it was debug information related. I don't really see any evidence of that. It just seemed like some unknown compatibility problem. The other profiler we were using, what was that called? CodeXL? That one had no problem running the profiler, but we weren't getting super useful results because it wasn't walking the call graph. So I think maybe that's a more accurate description. P in YouTube chat says it could be a 2-hour limit. No, there's not a 2-hour limit on YouTube streams. That was just because my computer was slow and the connection dropped and it didn't come back fast enough for it to treat it as a single stream. I feel like I've got a theory that, like, the longer you've been doing software for, the more time you just spend, like, telling other people no instead of yes. It's like, no, I realize you've been running off in this direction, but let's reel you back in. Actually, that's not the right direction. I don't know. Not to be super pessimistic. I just, like, that's something I have a lot of trouble with, actually, with like this aspect of teaching. It's like easy to push people in a particular direction. It's harder for me to redirect someone when they're already running super fast in a direction which is kind of right but not quite. It's like, oh, I don't want to destroy your momentum. You're going really fast in this direction, which is almost right. I just want to, like, nudge you a little bit. And that's something that is harder. Is this broadcast receiver or MPMC receiver? Broadcast receiver. This is supposed to block. Luna's on the desk again, and she's being super cute. Let's take a look at the threads again. I don't know about this. Also, I'm wondering if the CPU usage increases when I add more WebSocket clients. I guess this happens with science in general, like, or just like anything where you're trying to figure out a hard problem. It's like exciting to take a partial result and like blow it up and run with it, but being like actually sure about something is less exciting. But it's something that I like. Oh man, thanks for nuking all these YouTube chatbots, Peter. I might might be able to do something to automatically ban them if it seems like there are like particular keywords or links or something that we could do, but they've probably designed their spam to make it hard to do that. Can we see the threads here, or do I need Process Explorer for that? You know, I'm realizing that the bot is not turned on, and I wonder if that might be the difference between this situation and previously when I hadn't been noticing this bug. So I'm going to try turning on the bot and let's see if that changes anything. I don't really expect it to, but it would be worth a test. Oh, the CPU decreased after I turned on the bot. That's useful. Man, just adding more WebSocket clients actually does tax the CPU more than I was expecting. Wow. There's got to be some other problem behind all of this. Do I have Process Explorer? P in YouTube chat says, easy to click arrow report. I have no idea what you mean by that, sorry. Matt Druitt says, how many WebSocket clients are you making? One per web tab here, and maybe a couple of extras. If you're wondering whether it's reasonable for each WebSocket client to use like 12% CPU, of course not. We're debugging it, that's what we're doing. Oh, this is probably not the right tool. I actually just wanted CPU usage broken down by thread. Where is my bot server? Oh, in Process Explorer, go to the details. Okay. I should really just grab the whole suite. Oh, I see. P was talking about reporting the bots. Gotcha. Yeah, no, it's easy to get rid of them. You just have to notice them. Huh. That was a noise that didn't seem to correspond with any of the cats. Or... Oh, or Cloud, was that you knocking something? I don't even know. Oh, the cats are so complicated. It'll be nice to have less of that soon. Oh, this is nicer. This is what I wanted. Yay, look at that. CPU usage by thread. New thread start, yeah. It's also just possible that, you know, I'd been assuming from the level of CPU usage that we were seeing that this is something actually just being wedged. This stuff looks more than you would expect, but maybe that's just because it's an unoptimized build. So let's maybe try restarting this with the bot turned off to reproduce the earlier behavior. So here I just turned off the bot, and now you can just see the CPU quiets down. But let's try restarting it with the bot on. Oh, I just killed the thread, which isn't what I wanted. Of course, Control-C doesn't help. Right. Let's run it without WinBag. Still close WinBag. Bot controller. Okay, now we have a bunch of threads that are all competing for CPU up here. Are we sending messages when the bot isn't connected? Is that what's going on? Hey, Cloud, stop eating everything on my desk. Ugh. Oh, my FreeBub asks if the stack button works. Yeah, let's try it. I mean, these are probably just all the threads with the message bus receiver on them. Well, yeah, see, it's not linking the stack frames together. It knows we're in multi-queue receive, but I can't tell which multi-queue. I can refresh it and see if I get lucky. Oh. Yeah, I mean, I could try doing some source level debugging, but I think I might just add some printfs to some of the message receivers to see if they're receiving anything. It might just be we're getting into some state that causes the multi-queue itself to become more CPU hungry than I expect, but that seems unlikely. Okay, here's the bot. We don't have that many places where we're receiving, right? There's the controller thread, and then there's each WebSocket client. Let's start out just by adding it to that thread. There are a couple of other threads we might want to worry about, but controller is the most canonical one. Yeah, Vinci says maybe the queue gets into a state where the readers don't block anymore. It could be an error condition. Yeah, that's the kind of thing I'm thinking of. It's something along those lines seems kind of likely. I'm trying to decipher some emojis on Twitch chat. There's a cat, and then a flying cheese sandwich, and then a castle on fire. I don't think that's actually what it's supposed to be. Oh, it's a cat, a car spinning over, and then the car on fire. The car looked a little like a cheese sandwich. See, look at that, controller entering poll. Just sitting there. That's a good sign. If I turn on the robot, it should finish poll. This should eventually stop. Oh! No, it won't eventually stop, will it? That's fine, though. So this is creating a loop where the controller thread does periodic tasks on a couple of timers, but it checks those timers anytime it receives a message. So those periodic tasks won't be happening until you get the first message. But then after that, some of the periodic tasks end up sending out their own messages, like this one. So a lot of what you're seeing is the overlay drawing task we were working on a couple of streams ago. And so that's actually probably fine. It's a little spammy, but it's not just chewing up 100% CPU or anything. And the case we were worried about was before the bot turns on anyway. So let's try to get to the bottom of that. It doesn't look like this thread's doing anything, but let's take a look at the WebSocket threads maybe. It might even be worth actually just stopping it in WinBag with the robot turned off. Did I still have that in my... There it is. Yeah, sorry the stream's getting choppy occasionally when I run this. Usually I run my demos on a separate computer. This is just a weird case because I'm developing stuff that's for the stream. And I could temporarily put all this on a different computer, but that would just involve moving a lot of hardware around. And it's not the way I actually want this to work. Why are we inside an iter next inside multi-queue wait? I should definitely add some print debugging to these WebSocket bus receivers. Oh, that's neat. The reason we're seeing start WS bus receiver in this backtrace at all is that that's actually the namespace for this closure that we're in. That's pretty handy. I also wonder if maybe we end up with loops that are still spinning but associated with dead WebSockets. I also can't imagine how that would actually happen currently, but... just saw B3 Lips comment that the cheese sandwich is actually a flaming car. Yes. Clearly I've got lunch on the brain right now. Why do we have so many of these? Oh, well, I do have a lot of tabs open. Do these ever stop? This is starting to seem like a bug in multi-queue, isn't it? Oh, and it's getting really choppy. It's getting really, really choppy. Oh no. No, 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 no. No, yes, it's getting very choppy. All right, why was it using so much CPU? Like, that felt like it was even worse than an infinite loop. Like, it was doing something with the scheduler that caused it to like, bog down all the other apps. It's always fun when you find some scheduler corner case that lets an app take down the system entirely. I forget what it was. There was something I found, just like some kind of weird concurrency edge case that you could get when it was doing something super mundane. It was like passing messages from one program to another over a pipe in Linux. So it's like you have one thread write to a pipe, and then the other thread read from a pipe, and then looking at the performance characteristics of doing that context switch to get to from the source to the destination. And there was some edge case where I forget how we were triggering this, but only on Linux kernels that were built with NUMA support, so non-uniform memory scheduling, you could get into some edge case where just doing this very simple thing across a pipe would cause one CPU core to peg at 100%, and then all the other CPU cores would be idle, even though it was multiprocessing, and even though you always had work for multiple threads to be doing. It would get into some kind of weird scheduling hazard like that. Okay, so there are a couple of mysteries here. It's sucking up tons of CPU even though I don't see it exiting this receive. Also, we're getting a lot of WebSocket threads, but that could just be there are a bunch of browsers open on various computers in the shop that are all refreshing this page. Like, it shouldn't really matter that much to have a bunch of WebSocket clients. It's also possible this multi-queue module I'm using in Rust is not the right tool for this job, and I should switch to something else. It's also possible the multi-queue is just buggy. The thing where it just pathologically chews up CPU before I've gotten any messages, though, is just bad. And obviously I could work around that by just sending a dummy message when the bus is created. But, I mean, maybe that would be a good test just to see if that does work around it. Also, I didn't see any of these loops stopping. Let's try that again and see if I can get some of those to stop before the system just becomes unusable. So all those browser tabs are no longer still open. Jan asks, is it spamming threads? It maxed all cores. You mean, is it just like creating threads over and over again? Almost certainly not. John Smith is asking what I'm trying to do. Just debug my program, that's all. I mean, the top level task here is I'm making a robot it's like a remote controlled camera robot with some computer vision that can fly around my shop and live stream my cat or whatever. That's the end goal here. The current job is debugging. There were a couple bugs I was trying to solve. One is related to this WebSocket connection we were working on in the OBS plugin. This is not really going through with my connection, and I was trying to debug why. But in the process of debugging this, I noticed a bug that's bothering me even more, where before the server behind it, which is written in Rust, before that's actually received anything from the robot, it starts chewing up tons of CPU, and I'm trying to figure out what's going on there. Okay, where is bot controller? Okay, we've got a couple of threads. If our theory is that each thread that's just chewing up the CPU is one of the multi-queue workers, that would make sense because we should have two multi-queue receivers right now. There's the bot controller thread and one WebSocket client. And that WebSocket client has not had a chance to exit yet. It's just sitting there. So if we reload this, I would actually expect that might open up a second one without killing the first one, because if we're not receiving any messages, there actually aren't any opportunities for us to notice that the underlying socket is gone. So this thread might just stay around until the first message comes in. I think that's what I just described. So yeah, every time we reload this, we get another thread. Okay. So yeah, every new WebSocket connection, we get another thread that's chewing up CPU. That's great. This is looking a lot like a bug in multi-queue. It might be worth looking at how multi-queue implements receive to see if we could imagine how it might get stuck in this state. That stopped updating. Cool. Oh, interesting. MyFreeWeb says it looks like multi-queue might have a specific bug on Windows that we're hitting. Where did you see that? Or is it just a guess at this point? Broadcast uni receiver? I don't know what that one is. Future receiver. So many iterators. Implement. Oh, okay. I was reading this as implementation of clone at first, and no, it's an implementation with a trait bound of clone. That makes more sense. T here is the type of data the queue operates on, and this just means it can hold anything that can be cloned. So that's an inner receive. I should just check out this repo. What? What? Oh, okay. So this is just looping around. Okay, that's could be fine. But what is going on here? Is that just not implemented on Windows? This waiter? So this is an infinite loop, right? If this waiter was not here, that would completely explain what we're seeing. Like if this was just commented out. This does a non-blocking receive, and then if it's empty, we end up here. So if this wait function was just not working at all, that would completely explain the behavior we're seeing. And if that's true, then I definitely need to ditch this module. Because that'll just chew up tons of CPU for every thread I have receiving on this queue. Oh, waiter was on... Okay, where's our wait module? Why was this unsafe? Busy wait. Busy wait. Busy wait. Busy wait. Who's using that? Why? Is it just a component of more complicated wait schemes, or? Because there are occasionally reasons why you would want to have one processor busy wait rather than do a system call, but it's usually something you want to use extremely sparingly, and having that as a default seems bad. Which waiter am I using? Just looking at chat again, Jan says, so the kill is not working? Which kill? If you're talking about why the threads are not dying, I'm not trying to kill the thread. That's significantly not what I want. Killing a thread anytime the WebSocket client disconnects would make it really easy to just end up with broken mutexes and other problems, which you could actually solve in Rust. That just doesn't seem like the thing that I want to do. I think I'd rather have the threads exit cleanly. And having them wait a little while and then exit cleanly is fine. And that's what the strategy is right now. When you want one of these threads to exit, you set a flag, it checks the flag after processing the next message, and then exits. Vince says maybe the queue always spins. That's what we're trying to figure out. We're taking apart the queue and trying to figure out whether this is a bug or a misconfiguration or what. Like, no jumping to conclusions here. I'm sorry if that wasn't a conclusion and I misinterpreted it as a conclusion. But right now I just want to know which waiter implementation this is using. That futures weight thing is weird. This is just a weight. What is a weight? An unqualified weight. Oh, weight is a trait. Okay, where is that actually set up then? That's the default. It should be defaulting to blocking weight. This is how we initialize our multi-queue. It has a capacity. Why is this starting with an underscore? Actually, this isn't quite the constructor we're using. I think we create this as a broadcast queue. Let's make sure that's all still working in the exact data type we're using here. So multi-queue broadcast queue is how we're creating this. All right, broadcast sender, broadcast receiver. Okay, this is using multi-queue's constructor. Should be trying to block. None of that's broken so far. So, and let's look at the block implementation and see if we can get closer to that. And yeah, maybe it's possible we just find that it's just not implemented on Windows or something. And then maybe we patch it. But it might just be configured wrong. Like this. What are these defaults set to? Really? Really? 1,000 spin iterations. I mean, I'm sure that goes by pretty quick on a modern CPU, but this is kind of an advanced strategy. I'm just a little shocked that it's the default. Because this is sacrificing a non-trivial amount of CPU to get a little bit of latency in certain cases. We don't have to use this multi-queue. I can make my own thing. Like, I think maybe the easiest thing to build out of like MPSC channel, it would be maybe the best primitive to make this out of. I can imagine having one channel that goes kind of in the reverse direction that you use to register new consumers, and then each consumer would get a forward direction channel, and the broadcaster would just enqueue a new item into each of those receiver channels. There's actually one other benefit to ditching multi-queue, which is that I can implement a non-blocking send, which multi-queue does not have. Multi-queue only has a blocking send for when the queue is full, which I don't actually want. So yield. At this point, I'm not sure whether the problem is the behavior of this multi-queue being kind of fundamentally incorrect, or whether we're just burning more CPU than I expect because of the magnitude of these two values. So it'd be nice to maybe first try changing those. Waste some microseconds. Thank you. Thank you for wasting my microseconds. Are there any better queues? I am getting really annoyed with this library. A fast MPMC broadcast queue. For some definitions of fast. Okay. This seems promising. It's a little annoying that this has the same name as one of my existing internal modules. Maybe I need to rename my internal module. I mean, I could also rename this one, but it's just like semantically annoying. Let's take a look at the source code. Did that say fix, possible fix for memory? That's also not encouraging. Well, I mean, I'm happy to fix bugs in libraries if we find a bug in a library. It's just that multi-queue library, already had a bunch of strikes against it. Like I was kind of grudgingly using it rather than really loving it. So if I can switch to something else, that might be way better. Oh, they're spinning here too. At least they're using time instead of just a number of iterations. Yeah, on multi-queue, I don't know whether the big problem was the spin or the yield loop. Those both sounded pretty bad, and honestly, the yield loop could have taken a really long time, because I just like don't know what the Windows scheduler does when you tell it to yield a thread. And doing that 50 times per message, I don't know how long to expect that to take, right? A seat. A seat is apparently one of the receiver threads. This seems a lot nicer for my particular use case. Yeah, try broadcast. Oh, that's nice. This will need a little bit of refactoring though, on my end. All right, let's do this. Config.toml. No more multi-queue. Go away, daemon. Multi-queue. Bus. So I think, I don't know if we have any other uses of multi-queue. Mainly multi-queue is being used inside my module, which is also called bus, inconveniently. Yeah, bus.rs. Oh, lib.rs. That's it. What would be a better name for this? I kind of like this the way it is, though. Maybe I just live with the name collision. I don't know. That's really confusing. I think I should rename my module. It could be bot bus. That might be consistent with the rest of my naming. Just calling this bot bus. I wanted that to be case sensitive. The terminology here is slightly in conflict. This library is using the bus to mean the entire thing, whereas I was using it to mean more like a port that you can use to get messages from it. Or to send... Is bus clonable? I don't really want to... So it's sort of like before where I wasn't really rewrapping the multi-queue stuff. I was just using it as directly as I could. It seems to make sense to use bus that way also. Like, for example, I can imagine just passing... the trouble is this bus data type, the way we use it. Yeah, so we make the bus here in main. Where is it passed around? And then we just start passing references all over the place. The bus owns the canonical configuration state here. So I think controller... really? Controller should own that. It does own that. Yeah, okay, so here we're relying on bus being clonable because bus doesn't represent the whole thing, it represents ports to the bus. So I think instead of this bus object that we can clone, I think instead we'll want something you can't clone, but you use during initialization to create all the ports that you actually want. And so that actually is pretty much just a bus object from this module wrapping a message. Nothing special needed. The only reason it's weird here is that we were also having this wrap access to config. Maybe instead of bot bus, this is called bus access. This does actually, this object will be the bus. Like, this will no longer have sender and receiver in it. It'll have, yeah. Just something like that. And this is not going to be clonable. I like that a little better. It might also be permissible to rename this whole module to something like types. Since, I mean, that's very generic. There are a bunch of types in here. This file is mostly about defining types, but they are types related to the bot message bus and configuration. I guess I need a word that's more generic than both the messages and the configuration, because that's what this whole thing is about, and that's what this structure here is about. Interconnect, maybe? Interconnect feels very generic, also very long. I'm kind of tempted now to just plumb this new data type through everywhere, keep all the members private, and then just add methods to access everything I need. Because I've been on the fence about doing that for a while, because it was kind of bothering me how the details of this were being exposed a little more than I thought was actually good for maintainability. So this will be an opportunity to do a refactor I've been wanting to do for a little while. So go up here. It is just bothering me that this data type that I'm calling a bus has another data type called a bus inside of it. That just seems to be semantically bankrupt. I guess my other best thought is interconnect. adapter, because this isn't actually adapting anything. It's closer to a bridge. Well, then you wonder, like, well, what is it a bridge to? It's like a bridge amongst many things, which isn't how bridges work. And it's tempting to use a word like connection, for example, but that's very networky in this context, and I think we want to avoid that unless we're actually networking. Link, interconnect. It could be the bot fastener. No. The thing is, like, bus actually has a very specific meaning in this case, which is very, very close to what I want. Now it's just about having multiple levels of abstraction here, where there's a bus in general, and then there's the specific thing that we're using for both the communication of messages and of configuration data. Can't think of a better name. So actually, if we just let it compile now, the compiler should tell us everything we need to fix, or like at least point to all the areas. Really? Oh, right. This is now bot bus. Morgan suggests bot message hub. The problem is it's not just messages, though. The bus object that's just named bus will be for messages, but this also deals with configuration, and it happens to be a good place probably to stick methods that actually relate to any policy we have for how these messages are dealt with. Oh, I kind of like transport. Although then that kind of overloads with the idea that this, like bot transport, is that related to how the bot locomotions around the room, or is it about getting data to or from the bot over the network? I guess one reason I like interconnect is that it really is about the different modules in this same program talking to each other, which is what I'm doing. Bot message hub sounds nice, but it's not quite accurate. All right, gimbal. That's an old comment. There used to actually be separate buses for command and status. And then backing up a context one more, this is now Tuco Flyer : interconnect if we're looking at that scope, which I think that kind of works. It's a longer name, but I'm fine with that. You know, config is in a separate... Like messages could be a separate file too. Who uses this on the bus anyway? How much would it be better to just have the config reach those clients some other way? So botcom uses it to get bot addresses on startup. That's how we do config changes in controller. Yeah! Okay, I think I've got an idea for this. Maybe this file becomes more about messages than the bus itself. The bus is now actually just an external entity that we don't even need to worry about in this file. And this wart on the side of the bus where it's also storing the config, that just turns into a separate data type that's like a shared config. I'm just taking the refactoring scythe to this pretty hardcore right now. I don't know how much of this should be public. I don't know if you can debug a mutex like that. That also doesn't really make much sense. Just clone. Is that what we were doing? Yeah. message.rs. That seems a lot nicer. So maybe it doesn't need bus or ARC or any of that. It's just messages. Take Hertz is not a bad, this is like not a terrible place for that. I feel like that could go either here or in botcom. I feel like this should at least have a type definition for the particular type of bus we're using. How do you do type defs again? I almost never want the Stack Overflow answer to be first. I'd much rather the actual documentation be first, and then the Stack Overflow answer. It just feels like you're playing this big game of telephone, having to figure out who knows what they're talking about when you could just be reading the source material. That's not exactly what I was looking for. Type defs are new types. I just want the actual documentation for this is all. Type aliases, that's what they're called. Yeah. So I know that many of the other web pages I just visited had the exact same syntax, but the thing I was actually looking for is A, what is it actually called? B, where am I actually supposed to find it? And C, how do I memorize this for later? And reading a random Stack Overflow page would not actually answer any of those questions reliably. So I actually want to define a message : bus in addition to the bus : bus. I think that's maybe the way to do this. That's so much better, I think. So now when we do this, we're actually going to export that bus type def, which should be great. Wondering whether to expose that config file and the shared config, or whether to layer those together. This is me just wondering if the shared config should be a shared config file. Maybe the config file should have sharing built in. It's also the one that yeah, because it's also the one that kind of keeps the sending and receiving ends of the save channel separate. Let's just merge that in so that shared config is actually just a feature of that config file module. So that would be arc mutex config. So pathbuf is immutable. The config itself can change, and it can be shared by multiple threads, and it'll be reference counted. The save channel, I just want none of this to be public. Why does any of that need to be public? Path can be public. These other two I probably want to access only through member functions, yeah. There isn't that much of a reason why this even needs to have the path, honestly. Alright, so we're opening the config file, giving the path to this other thread, creating a channel between threads that lets us send a new config to save. These definitely don't need to be public. This was also before I knew you could just do ampersand self in Rust. That seems fine. Merge values. Oh, that's in config.merge. Okay, that's probably enough for this module for now. So we've got config file, which this should be clonable, because this is now shareable. We can share this config file among multiple threads, and they can all load and save. So happy. Maybe this name should be like shared config file. think that's all the changes for this file. Let's see what the compiler says. Let's just start propagating this outward and give us some new stuff to work on. Right, lib.rs. Can I do that? No. Oh, Luna found the camera again. Oh, 69 viewers on YouTube. That's pretty nice. Game Frenzy on Twitch says botnet parenthesis work. Bot network. Yeah. Ah, see, there's some good errors. No field sender on blah 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 bus timestamp message. That's great. Let's have a better message send. So that also kind of forces us to think about the difference between the bus we have now and the separate reader and writer ports that we should be using. Let's get the documentation for this. Yeah, maybe documentation, not source code. Add RX, add TX. Okay, you don't need to explicitly add transmitters, just receivers. That's good. Yeah, try broadcast is pretty much exactly what we want to wrap here. Or not wrap, but just use that. That's right, I was still mentally back one level of design where I was still having a wrapper here, but we're not wrapping it, we just have a type def. So, where were we? Gimbal polar. Gimbal polar still needs some work, but it should be using the right message bits and pieces at least. So this would be bus dot try broadcast. Same value here. Same error result that we're ignoring. That's nice. Same treatment for gamepad. This is not as big as of a semantic gap as I was thinking. I thought we had to add writers explicitly as well, but the writers come for free with a copy of the bus, which makes more sense. Oh, am I trying to... Wait, you can't share an MPSC sender, right? Oh. Wait, is bus not multi-producer? That's right. So we were actually relying on this being multi-producer. This is so close to being what I want. I mean, I could send all my incoming messages directly to the controller thread. The reason for the broadcast is because most of these messages I'm going to want to process from all the WebSocket clients as well as from a couple of internal threads, but mostly this controller thread. Like there could just be one thread that's responsible for moving messages from a multi-producer single consumer queue to this one, which is effectively a single producer multi-consumer queue. But is that real? Is that really the limitation we're into here? Yeah, single producer multi. Okay, I didn't notice single consumer earlier. That would imply why you can't add transmitters. So who owns the transmitter in this case? Is it the controller thread? Don't really like that. I mean, I could have my own object that wraps all this again and actually just forward stuff from an MPSC channel to this broadcaster. I mean, it would actually still be decreasing the total number of threads going on because I could delete my... There's like one thread per WebSocket client that I'm using pretty much entirely just because I don't have a non-blocking write for the multi-producer, multi-consumer broadcast queue. Oh, Vevasaur says they dropped by and I'm in head-holding mode, either in deep contemplation or minor frustration. This is a robust combination of both. Is that Sast Monkey in YouTube chat says, what language is this? C++? We were doing some C++ earlier, but this stuff right here is Rust. This is kind of starting to come back to my previous strategy where I had, I mean, not like previously today, but like much older, where instead of a single multi-producer, multi-consumer queue, I had separate queues for events the controller's producing and events the controller's consuming. So I could imagine doing something like that where the controller basically just has input and output queues. The input queue is multi-producer, single consumer, and the output is single producer, multi-consumer. And how would that work? So some input comes in from the robot. There's the bot com thread, which is waiting on UDP. And it gets the message, sends it along to this multi-producer, single consumer channel. Other input sources like the gamepad do the same thing. They get combined in the channel. All of those get funneled into the controller, which processes some of them. Relays all the messages to the output queue. So you can listen to the output queue and see the same messages that were coming in from the input, but then it also adds its own messages. I kind of like that. That means instead of having a bus at all, maybe it's more like we have an object that we use to access the controller's inputs and outputs. So we have the controller, and then also terminology here is a little bit overloaded. When I say controller, I mean a thread that controls the robot. There's also like a video game controller, which is called a gamepad here to differentiate it. So the controller could have like a controller remote, or controller connection, controller I/O, controller port, although that also sounds like gamepad. But something to indicate that this is how we access a controller, but it's not the controller itself. And then that object would be clonable, maybe. how do I generate receivers for the bus, though? So if that bus object has an addRx method to get a receiver, but the bus is single producer and therefore not clonable, that's a chicken and egg problem. I mean, you can make a bus, make all the receivers you're going to need, then send those to separate threads. But I need to be able to add receivers dynamically. I mean, you could do something convoluted where you send a message asking it to send you back a receiver. Right now, all the messages are JSON serializable, though, and that would kind of break that trend and be kind of hugely messy. It seems like a layering violation. Clearly I need a gamepad controller, yeah. So, still thinking about how to do this like bot port or whatever, or controller port. Controller access, maybe? Controller remote? Something like that. So that object would need a way of sending a message to the controller. That would just turn into a send into an MPSC send channel, which is clonable. Because I want this object to be clonable, ideally. Okay, and then there's receiving, though, which should be optional. Like, just cloning the bot controller port access or whatever, cloning whatever this object we're designing, that shouldn't add a new receiver, because adding a new receiver is basically asking for an additional copy to be made of all the messages. It's not free by any means. It's something we want to do when we need it. So this object that is clonable should allow you to request a new receiver. But it sounds like I'm going to have a separate channel pair that's just used for requesting receivers. So maybe it's a channel that the bot controller has a receiver for. Because again, these are single consumer channels. So the bot controller has the single consumer, but then anyone can send a message to it that includes a sender for their own channel that asks it, hey, by the way, I know we don't know each other, but could you send me a new receiver, please? And then the bot controller would get around to processing that and then send a new receiver back. That seems fine. That little back and forth would have to happen every time, say, a new WebSocket's connected, but that's fine. I'm kind of liking that. Ryan says put everything on the network and let UDP take care of it for you. It is on the network. You're suggesting that I use broadcast UDP packets as a solution for this. I mean, it might be better than multi-queue, but yeah, it wouldn't be so great. Anyway, I like this strategy. This is mostly me running out of energy and probably needing to eat lunch rather than being frustrated at this point. But yeah, I think I've got a strategy for this. I think the strategy is we ditch multi-queue. We do use this single producer multi-consumer bus, because that does seem to be the primitive we want, but it does need a little bit of a layer on top in order to request additional receivers across threads. So I think that's the level we're at. Anyway, I'm going to use the restroom and see if I've got energy to continue this, but I should probably quit this and get a bite to eat and work on some other stuff for a little while. As much as I'd like to make progress on this, I don't know that right now is the best time for it. Yeah, back. Yeah, I think this is probably a good time to wrap up the stream. Because while I probably could muster some more work here, I think I should maybe go back to plan A.5, as is often the case, which was to save some time this afternoon for working on my B-sides talk that I need to finish in like the next week. So, yeah, as much as I'd love to just binge on this as much as possible, I think I'm gonna say goodbye and work on some other stuff this afternoon and get a bite to eat. But let's have a little bit of Luna first. Yeah, eating can be quite healthy. I think I'm gonna try some. Oh. But yeah, just to recap a little bit. So I started this stream intending to just continue with the OBS plugin work we'd been doing before, but then just kind of stumbled on this really nasty performance problem with multi-queue. And we didn't really get entirely to the bottom of that performance problem. The tools for debugging that aren't so great right here, but it looks like it's likely that it isn't like any one single egregious problem. Like it isn't like it just isn't blocking at all. It is blocking, at least it seems like it is. It looks like it's just that the implementation has a default behavior which wastes a ton of CPU per client. So yeah, it might just not be the right implementation to use. Cloud is down here, and I'm fuzzing him. Cloud, can I fuzz you up here? Oh. What? I have to hold the camera up. Hey, Fuzzboy. Ow, ow, ow. Okay. All right, well, thanks for joining, as always. I will see you folks later. Happy hacking, folks.